Hello all, and welcome to this week's episode of The History Dudes. Today, we'll be touching on an incredibly interesting topic. It's a subject which allowed early civilizations to grow from simplistic roots to complex bureaucracies, and has allowed us to push the boundaries of what is possible when it comes to the human mind and body. Mathematics will be at the center of the talk, but more specifically, representations and how they allowed early civilizations to push their abilities in both sciences and humanities. Humans have had some understanding of the concept of numbers for as far back as they were drawing mammoths on cave walls, and probably even longer. The need to count was necessary for fairness of division of resources amongst early peoples. It also was necessary for knowing how long until important events occurred, such as the number of days to the next watering hole or the time between growing seasons. The earliest evidence found of human counting is a set of notched bones dating back to around 44,000 BCE. These bones were found in Border Cave in South Africa, and the system of counting found on them is remarkably similar to the tally system still in use. From these early roots of counting, humans were able to slowly advance society. With these more advanced societies came the necessity to advance the complexity of numbers. One of the earliest civilizations to push numerical representations to new heights were the Sumerians, whose discoveries were then carried on after their fall by the Babylonians. Sumerians utilized a base known as sexagesimal. It is unknown exactly where this system came from. However, it is a very easy system to count utilizing only the body parts we were given. Most people have 2 hands, and 4 fingers and a thumb on each. On one hand, the 4 fingers were split into 3 using knuckles for each. And on the other hand, the 4 fingers and thumb were counted from 1 to 5. When they first developed this system, they utilized symbols such as jars and wheats to denote large numbers in transcriptions. Over time, they transitioned to a more abstract system. They began using the same cuneiform stylus as their writing system. This allowed them to streamline to represent large numbers and number sets. Sumerians took this denotation one step further through the creation of a left-to-right place system. This allowed them to make representation of numbers far larger than 60. They were one of the first civilizations to do so, prior to the Egyptians, Greeks, and Romans. The main reasons for Sumerians and later Babylonians had for developing complex system of numbers was to fulfill bureaucratic needs, to keep track of taxes, land ownership, and other necessary facades of large communities. The streamlined representation of these values made it much easier for records to be kept for anyone within the civilization to. Though development of the system was originally for bureaucratic reasons, over time, it pushed more deeply into their society. In academic pursuits, the society was able to expand their knowledge of astronomy, geometry, and algebra, all thanks to their representation system. They built complex and beautiful structures, much grander than many other societies at the time. They were also able to create some of the first financial systems and understood the idea of compounding growth to increase wealth. Probably one of their most interesting and heavily disputed discoveries is their knowledge of the Pythagorean theorem nearly 1,000 years prior to Pythagoras. The most known concrete examples of this knowledge is a clay tablet known as Plimpton 322. This tablet seems to have many sets of Pythagorean triples listed on it. The existence of this tablet shows that the society did have at least some knowledge of Pythagoras' theorem. However, no formal proof has ever been found which confirms that they were able to derive the full theorem prior to Pythagoras. Although we no longer utilize a sexagesimal system in most mathematics, it is still a system we use daily. We can see that mainly in timekeeping, with an hour being 60 minutes and a minute being 60 seconds. It also does still have measurements being derived from this system, although they are slightly different. Also, 12 inches in a foot is another way which this system is still felt today. The Sumerians and Babylonians were very advanced for their period, and clearly held a significant knowledge of mathematical systems. Their ability to streamline the representation of mathematics and their development of a place system cannot be understated in the importance to the advancement of mathematics.
Moving farther east from the Sumerian and the Babylonians, we encounter the Chinese. From a very period, the Chinese began to represent numbers using abstract symbols. The earliest evidence we have of this representation is transcription on a tooth shell, which dates to approximately the 14th century. The Chinese The Chinese utilized a base 10 system akin to the one we still use today. They were the first society to develop a decimal system, doing so nearly 1,000 years prior to the earliest development in the West. This system popularity throughout the region. It influenced the early mathematical systems which took hold in India, Korea, and Japan. Many of the early use of numbers seemed to pertain to war and hunting. Inscriptions found donate the number of men killed in battle, the number of prisoners of war taken, or the number of animals killed on an outing. However, there are also some denote the number of days and months that have passed. From there, their number system grew to fulfill many other needs. The topic of mathematics and numerical representation began to take off as the society grew ever larger and the emperor needed competent administrators, much like other early civilizations. Numbers become the necessity for understanding trade, taxation, engineering, and payment allowed their society to avoid many of the growing pains that tribal societies faced. Another major reason for the development of numbers and early mathematics in ancient China was to help control the environment. Many earlier Chinese societies took hold around the Yangtze and the Yellow River which runs through China. The problem with these regions is that they are prone to flooding. In order to control this flooding, the society engineered sophisticated systems of dams and canals to help direct flowed water. This gives them the ability to establish themselves in previously uninhabitable fertile land. Although it was necessary for the initial establishment of the society, over time and the subject of mathematics in China grew immensely, and it did so long before many other civilizations. However, over the years, many of their discoveries were lost. Amongst the many important discoveries was their use of matrix-based problem solving. This system allows for the problem solver to derive an unknown quantity from the other known quantities through the utilization of elimination. It is unclear when this system was known in China, but it was long before Gauss rediscovered this form of problem solving in the 19th century. Gauss' method is now known as Gauss elimination. Despite it being first discovered in the East, the Chinese system is one of the few that did not originate in the West that was nearly identical to us accepted system today. Their use of a system has a clear resemblance to the one commonly used now. Many of their problem-solving techniques they developed are still used in advanced mathematics, despite many of them being lost, forcing youth to rediscover them.
It may be easy to blow off the creation of number systems as regional if we were to stop here. The Chinese, Sumerians, and Babylonians existed within the same region. Although they were thousands of miles apart, it's not hard to imagine that there was some form of knowledge passed from one group to the other throughout time. However, if we travel over to the Americas, we can see that this was not just a regional phenomenon. It was in fact a topic which permeated throughout almost every society. One of the most advanced number systems created in the Americas was the Mayan number system, created soon after the Mayans came into existence in 2000 BCE. The Mayans created this system because astronomy played a large part in their society and was viewed as their connection to the gods. They used this number system to help understand and represent the calendar, as well as the large calculations they needed when they were creating their calendar. Although it may look confusing at first, the Mayan number system was very easy to understand. There are three main symbols you need to know. A 0 is represented by a shell, a multiple of 1 is represented by a dot, and a multiple is represented by a line. The Mayans used a base 20 system that originated from counting on your fingers and toes. The number 5 is represented by a different symbol rather than 10, 15, or any other number, because that's how many digits there are on a hand. The Mayans' base 20 system represents the numbers 0 through 19. After 19, numbers were represented in multiples of 20 on rows above the first row. This made it very easy to calculate large numbers, as all you have to do is multiply the row value by the symbol in the row, and then add it to the value of the rows below. The system they used also made addition and subtraction very easy. For example, the number of dots and bars together. If you end up with more than 5 dots, just convert them into a bar. If you end up with a number more than 20, take the number mod 20 and add the remainder to the first row. For subtraction, just take away the number of dots and bars to get your number. If you're subtracting more dots than you have available, convert a bar into 5 dots and subtract from there. Unfortunately, we did not discover the existence of the Mayans until around 1502, and by then their civilization had greatly declined, and was not even close to the glory and scientific prowess they had previously been. Because of this, the Mayans' number system has very little impact. Used their calendar to compare important dates they discovered to our calendar, as they predicted dates thousands of years into the future. Overall, most of the mathematics from this period have been integrated into our current system, but it's hard to tell how much any one society influenced our current knowledge. In the end, everything we see today would not have been possible without the early understanding of numbers and mathematics. Without this understanding, bookkeeping would be sloppy, and the ability of civilizations to grow would be hindered. It's hard to believe that we could be anything more than a nomadic species without numbers.